All right, guys, so last time we talked about this idea of all of these different signals that code for long, slow endurance exercise adaptations and short, high intensity interval adaptations. And now what we're going to talk about is what these things are doing. So we do the high intensity work, we get a lot of AMP kinase activity for a short period of time. We do long, slow endurance exercise, we have a small increase in CAM kinase activity for a long period of time. And those two things are now giving us something that's going to alter transcription, and it's going to alter transcription of this, what we call master regulator of mitochondria. And this is the cofactor PGC1 alpha. This is the peroxisome proliferator PPAR. So activated receptor gamma, and it's the coactivator. Okay, you don't need to know that. It took me 5 minutes to figure it out there, so just know it as PGC1 alpha. All right, so last time we talked about this long, slow duration. It's going to increase calcium. That's going to increase CAM kinase. That's going to give us an increase in this unknown thing at that time. High intensity exercise is going to give us this activation of AMP kinase. And both types of exercise, whether it's coming from pyruvate to lactate, regenerating NAD, or whether it's in the TCA cycle where we're generating lots of NAD, those are both going to give us SIRT1 activity, and that's going to also play a role in this adaptation here. And really what we're talking about is we're talking about increasing the transcription of this cofactor PGC1 alpha. All right, so by the end of this series of videos, you should be able to name the transcription factors that are needed to increase PGC1 alpha. You should be able to draw the transcription of PGC1 alpha after exercise. And you should be able to explain how transcription factors are regulated by AMP kinase, calcium, stress, epinephrine, and I should add on to there, it should be on there as number 5, oxidative stress. Okay, so really that's the core of what these videos are going to be. And this all starts back here in 2002 when this Yahoo doing a postdoc in the Professor John Hollisey's laboratory did a simple experiment where he took rats and he had them either do nothing, or he did a long period of exercise. So it's 6 hours of swimming exercise. And basically all you do to swim rats is you get a big barrel of warm water and you put 3 or 4 or more rats into there. And then rats have this, they don't like to swim, but what they'll do is they'll try and grab onto anything that looks like an island. And so usually that's another rat. So they climb up on top of each other, they grab each other, they circle down, they go to the bottom, and then they swim up. And they're totally cute when they're doing this. And about halfway through, we take them out, we rub them with a towel, and they sit there like a very small dog, and they let you dry them off. You put them back in after a half an hour for another 3 hours of swimming, and then dry them off at the end. And then we collect their muscles 6 or 18 hours after exercise. And so what we did is we took those muscles and we isolated the RNA, and we looked to see how much of the full-length PGC1 alpha mRNA we saw. And what you can see is there's an increase by 6 hours, and it's almost a doubling by 18 hours. But it's a relatively, it doesn't look massive because there's this other thing happening here. And this was totally unknown at the time, but basically there's an alternative form of PGC1 alpha that's not there at rest, that increases in the first 6 hours of exercise, and it comes really, really high up after 18 hours of exercise. And this was the first report that this master regulator of mitochondria, PGC1 alpha, is increased both at the full-length protein, or at the full-length messenger RNA, but that there was also some sort of alternative form of this. We had gone on to show that this alternative form lacked exon 8. So that's the exon that encodes the part of the protein that is the inhibitory domain of the protein. So not only are you making a lot more PGC1 alpha, you're making a PGC1 alpha that can't be inhibited anymore. So now you're making this high activity PGC1 alpha. And this is the PGC1 alpha that everybody is now going to be measuring. And this is the promoter. The promoter that we're going to look at is this alternative promoter, PGC1 alpha. And this is the one that's activated by exercise in our heart, our skeletal muscle, and to some degree in our brown fat, if we have brown fat. All right, so this is the promoter that we're going to look at how it's regulated by exercise, because you can see that exercise is turning on this very, very specific promoter that is going to give us a slightly different PGC1 alpha mRNA.